Hello everyone. Today we are going to see the concept that is designing of level shifter circuits or level translator circuits. We know that the level shifter or the level translator circuit is used in op-amp third block. What is the main purpose of level shifter is to shift the output DC level towards the ground potential with minimum change in AC. Okay, this is the main purpose of using level shifter in the internal block of op-amp. Now let's see the problem. So that is for the level shifter circuit. This is the level shifter circuit they have used. For this, the input DC level is 6.84 volts. Means the input signal that is appeared at the level shifter circuit having a DC level as 6.84 volts along with AC, and the R2 they have given 270 ohms. They have asked choose the value of R1 in such a way that the DC level at the output signal must be 0. Means we have to choose the R1 value to the circuit in such a way that the output signal or the output of level shifting stage must be having a 0 DC signal along with AC. Okay. If you observe that here the input is given at base terminal and the output is taken across the emitter terminal, and that too it is across the resistor R2. Means input is given to base and the output response is taken from the emitter terminal. So it is nothing but this configuration is common collector configuration. We can call it as emitter follower, which means that the input signal is always equal to the output signal. So here whatever may be the AC signal that is present at the input of transistor is same AC signal is propagated through the output, but the main point here is the DC level present at the input should be bring down to 0 to the output signal containing a DC value. This is the main motto. Now let us see what are the given parameters in the problem. So given the input DC value as 6.84 volts, but we don't know what is the input AC signal. That's why we are assuming it as some unknown value, that is X. Okay. Now what they have given, the DC level at the output signal must be 0. Means the DC level at the output is 0, and also they haven't mentioned what is the AC signal at the input. Since it is an emitter follower circuit, whatever the AC signal that is present at the input side, that will be propagated to the output. So that's why again the V0 of AC is equal to VI of AC. Here we are taking as X, so it's as X. Okay. Now they haven't considered which type of a transistor is used. So assume that the transistor is of type silicon and the cut-in voltage of a silicon is 0.7 volts. Now we have to do the analysis in order to find out the output voltage V0. If you observe this, V0 is nothing but the voltage drop across the resistor R2. Okay. Now let us see the circuit. Here from the Ohm's law we can write V0 as entering current, that is I into R2. So V0 as I into R2. So from this circuit we have to find out what is the value of current I. Okay. So by applying KVL we will find the value of current I through this base emitter loop. So let us suppose consider this is the input signal. Okay. So the entering signal, that is Vi, and here the base emitter signal VBE, and the current flowing through the resistor R1 and R2. So here we are considering as plus minus. So we know that the current always flows from higher potential to the lower potential. Okay. So now by applying KVL we obtain that it is minus Vi plus VBE plus I into R1 plus I into R2 equal to 0. If we solve this equation and find out the value of I as Vi minus VBE by R1 plus R2, by substituting the value of I in this V0 expression, we will get V0 as Vi minus VBE by R1 plus R2 into R2. This is how we are obtaining the output voltage expression from this circuit. Okay. Now in these equations, we know that the value of R2 is 270 ohms and the cut-in voltage of silicon is 0.7 volts. And here the input signal we are obtaining both, we are containing both AC and DC signal. The input DC signal they have given, that is 6.84 volts, and the unknown input AC signal we are assumed it as X. Okay. From this expression we have to find out what is the value of R1. The value of R1 can be found by taking this denominator term to the other side. So that is V0 into R1 plus R2, which is equal to Vi minus VBE into R2. Here the V0 signal consists of both DC and AC. Similarly, the input signal consists of both AC and DC signal. They have given what is the input value of DC signal and what is the output value of DC signal. So the input value of DC is 6.84 and the cut-in voltage is 0.7. R2 value they have mentioned as 270 ohms and the V0 of DC is 0. Since for the common collector circuit or the emitter follower circuit, we know that the input AC signal and the output AC signal is same. We are assuming it as some unknown value, that is X. Okay. Now for the ideal condition, let us assume that, or for the ideal condition we know that for the common collector configuration the voltage gain value is ideally equal to 1. So assume the X value as 1 and substitute in the above equation, you will obtain the value of R1 as 1.657 kilo ohms. In this way we are designing the resistor value R1, that's value is 1.6 kilo ohms. If you maintain this value in the given circuit, you will definitely obtain the output DC level is 0. Thank you.